Dear students, here the s equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of parallel lines. Then we saw that h square equal to ab and af square equal to bg square, and also we find the distance between the parallel lines is the 2 into under root of g square minus ac into a plus b. What is the students? The g square minus ac. This is not b. The g square minus of ac by a into a plus b, or f square minus bc by b into a plus b. Now students, here the given equation represents a pair of parallel lines. Then we saw that these conditions. Now students, the given equation represents the parallel lines. We are taking the first equation lx plus my plus n1 equal to 0. This is the first line. Lx plus my plus n1 equal to 0. And the second line lx plus my plus n2 equal to 0. So dear students, what we observed, these are taken as some 1 and 2. Undoubtedly 1 and 2. So here what we observed, the constant is differ by only constants. The slope of the line is minus L by m. The slope of the second line is minus L by m. Therefore students, these two lines are parallel. The combined equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to student, this is lx plus my plus n1 into students lx plus my plus n2. This is lx plus my plus n1 into lx plus my plus n2. Now students, equating the alike coefficients on both sides. The x square coefficient is here students lx into lx, l square. L square is the a. Now student, the xy coefficient is, this is lmxy, again lmxy, 2lmxy, 2lm equal to 2h. Now student, the coefficient of y square is the b, where the coefficient of y square, my into my, m square y square, the coefficient of y square is m square. Now students, the x coefficient is there here 2g. Now their x coefficient is, this is the students lx into n2, l n2. This is l1 n1 into x. So l is the common, n1 plus n2 is the coefficient of x. Now students, the coefficient of y is there 2f. Here students, this is the y term. This is m n2 y. m n1 y. M is the common. Similarly, n1 plus n2, m into n1 plus n2 is the y coefficient. Constant will be the students, this is the constant n1 n2. So students, the constant c is the n1 and 2. Now students, 2 is cancelled here. They are asking the first one h square equal to ab. The left hand side, what is there? Left hand side is the h square is there. The left hand side is there h square. Dear students, h is, we know that the h is here, h equal to lm. H is the lm whole square. This is the students l square m square. L square is, we know that small a. M square is the small b. This is the a into b. So student, this is the right hand side. The h square equal to ab. First proof is completed. Now students, here this is the 2g. This is the 2f. The second proof we can written as 2g by 2f divided by 2c and 2f. That is the students l into n1 plus n2 whole by m into n1 plus n2. Dear students, 2 is cancel, n1 plus n2 is the cancel. Now students, squaring on both sides, this is g square by f square equal to L square by m square. Is it clear students? G square by f square. Dear students, g square by f square, we can written L square by m square. This is g square by f square. G square by f square equal to L square by m square, or L square is the small a, m square is the small b. After then students, the cross multiplication, af square equal to bg square. The bg square equal to af square. This is the second one. bg square equal to af square. So dear students, first the given equation represents the parallel lines 1 and 2. The combined equation of the 1 and 2 is the product of these two equations. That equation we are equating the alike coefficients. We got small a L square, 2h lm, 2lm, b is the m square, 2g is the L into n1 plus n2, 2f is the m into n1 plus n2, c is the n1 n2. First we take h square. That is the students, h square is the lm whole square, L square, m square. L square is the small a, m square is the small b. Now students, we take the division. We take the division 2g by 2f. In that case, L into n1 plus n2, m into n1 plus n2. These two are cancelled. After squaring on both sides, g square f square equal to L square by m square. Here we are taking squaring on both sides because L square we know that small a, m square is the small b, L square small a, m square is small b. After the cross multiplication, we got bg square equal to af square. These two proofs are completed. Now the distance between the parallel lines, either it is 2 into root of g square minus ac by a into a plus b, or 2 into root of f square minus bc by b into a plus b. First write down this is. Now students, the distance between the parallel lines. So here the distance between the parallel lines, we know that the distance between 1 and 2. 1 and 2 is the students, those are parallel lines. These two are parallel lines. So the distance between them is modulus of c1 minus c2. That is modulus of n1 minus n2 by root of L square plus m square. Is it clear students? The modulus of n1 minus n2 by under root of L square plus m square. This is, we can written as the students, modulus of a minus b. We can written as n1 minus n2 whole square under root of, this is the students L square. L square is the small a, m square is, what is the m square is small b. Now this is, we know that this is the students, everybody know that the n1 minus n2, that is a minus b whole square. A minus b whole square is a plus b whole square minus 4ab. This is the students, we know that in terms of a plus b whole square, a plus b whole square minus of 4ab. This is students, we have to take as since we know that the value of n1 plus n2. So dear students, n1 plus n2, we know that that value is 2g into L is the by L, 2g by L. That's why we are taken as the n1 minus n2 whole square can be written as in terms of n1 plus n2 and n1 n2. n1 n2 we know that c. So this is the students root of a plus b. Root of a plus b. Dear students, now we are substituting root of n1 plus n2. What is the n1 plus n2 is 2g by L. 2g by L whole square. This is the students 2g by L whole square. So definitely students, when you are taking the n1 plus n2 2f by m, definitely we got the second one. So right now we saw that the first one. So the n1 plus n2 is the students 2g by L. n1 n2 is the students, we know that c under whole by a plus b. Right now we take whole root. My dear students, this is 4 g square. L square is there. L square is the small a minus of 4c upon a plus b. This is the students, we are taking the common factor is the 4. Root 4 is the common. 4 root 4 is the 2. G square a into c, ac. We are taking the common factor 4. The LCM is the a into a plus b. This is the students, the distance between the parallel lines represented by the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So the distance between them is, the distance between the parallel line is 2 into root of g square minus ac by a into a plus b, or 2 into root of b square minus 2 into root of f square minus bc. And another one is the students, similarly we can prove, similarly we can find out, that is 2 into root of f square minus bc by b into a plus b. This is students, how to get this one? We are taking instead of n1 plus n2, if you are taking instead of n1 plus n2 2f by m, 2f by m, that is 4f square by b. Undoubtedly students, instead of we are taking n1 plus n2 equal to 2f by m, we got this proof. 2 into root of b square minus 2 into root of f square minus bc by b into a plus b. Okay students, the second degree non-homogeneous equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of lines. Then the conditions are, first condition h square equal to ab, and the another one bg square equal to af square, and the distance between them is 2 into root over g square minus ac by a into a plus b, or 2 into root of f square minus bc by b into a plus b. Okay students, write down. Now students, the point of intersection of the pair of lines ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. If h greater than ab, dear students, here undoubtedly ab minus h square is there. So dear students, if you are taking, undoubtedly these are equal, h square equal to ab, it will be 0. That's why here is given that h square greater than ab. Then students, all of you listen here, its point of intersection is hf minus bc by ab minus h square comma gh minus af by ab minus h square. My dear students, we know that the ax square plus 2hxy plus by square equal to 0. This is the pair of lines which are passing through the origin. The point of intersection of the pair of lines The point of intersection of the pair of lines represented by the equation is the origin here, which are both are passing through the origin. Its point of intersection is the 0, 0. But students, here this is not passing through the origin. My dear students, what we observe here, the pair of lines are passing through the origin. Here the given equation represents the pair of lines. Undoubtedly students, this is the point of intersection. This line is parallel to this line and this line is parallel to this one, whose point of intersection, suppose we are taking alpha beta. So dear students, in the change of axis, so suppose the student, this is the origin, suppose we are taking the origin, this one, this is shifted to the point another h comma k. Here this is the small x, this is small y, this is the original axis, this is the capital X and a capital Y. So when the origin is translated to the another point h comma k by using this translation, that means the axes are, when the axes are translated to the another point without changing the directions of the coordinate axis, then the transformation is called translation of axis. So students, definitely I will explain at the time of change of axis. This is the students, all of you listen here. This is small x comma y. This is the students capital X comma. Now student, here this is original coordinates. We know that this is the small y, this is the small of x. Now student, this is undoubtedly, this is the k, this is h. Therefore dear student, this is x minus h. We know that these are the capital Y and capital X. So the capital X equal to x minus h, the capital X equal to x minus h, small x equal to capital X plus h. Everybody know that the formula is, here the small x and small y is the original coordinates, this is the new coordinates. The relation between the original new coordinates is, when the axes are translated to the point h comma k, small x equal to capital X plus h and small y equal to similarly capital Y plus k. This is the transformations. So definitely I will explain once again at the time of change of axis. Dear students, here is there already h is there here. Definitely instead of h comma k we take the point of intersection alpha comma beta. So we are taking the students the point of intersection. Let the point of intersection of the pair of lines is the alpha comma beta. So students, the small x equal to, just now I explained capital X plus alpha, and the small y is the students capital Y plus beta. So now find the transformed equation of this one. Dear student, the transformed equation of this one is the small a. All of you write down the new equation. The transformed equation or the new equation is a into capital X plus alpha whole square, 2h into the small x is capital X plus alpha, and the student small y is the capital Y plus beta, by square. Y square is the students y plus beta whole square. After then 2z into the small x is capital X plus alpha. After then students, the 2f into capital Y plus beta plus c equal to 0. Dear students, now we can written as this is a into x square, ax square. This is the first one. Here this is the students 2h x into y xy. This is the 2h of, now the simplification, this is x square plus 2 alpha x plus alpha square. Now student, this is 2h x into y xy. After then beta into x beta x. After then multiple with alpha alpha y plus alpha beta. Now students, b into y square 2 beta y plus beta square. So that is the students 2gx 2g alpha. After then 2fy plus 2f beta plus c equal to 0. But dear students, from this we can written as, how to write this is a into x square ax square. This is the students 2h xy Now the students b into y square, by square, ax square, 2hxy, by square. This is enough. These are the first two terms. After that, students, the coefficient of x is the students here 2a alpha. Here the students, the coefficient of x is 2h beta. Yes, 2h beta. After that, student is there 2z. Now students, the coefficient of y. The coefficient of y is not there here. This is the coefficient of y is the students 2h alpha. Here the coefficient of y is 2b beta. After that, student, this is 2f. Now the constant of the students, what are the remaining here? This is a alpha square. This is the students 2h alpha beta. This is the students b beta square and 2g alpha, 2f beta. Finally is there c. Now students, then it is we are finding here the origin is shifted to the another point. Suppose students, we are getting the origin. Origin is shifted to the point alpha comma beta. Now students, when it is a homogeneous equation, definitely student, the coefficient of x it will be, and the coefficient of y, this term and this complete term must be equal to 0. What is the students? Now students, when it is represents a homogeneous equation, the coefficient of x and coefficient of y and this term is also equal to 0. Now students, when you are taking the coefficient of x and coefficient of y 0, that is 2a alpha, 2h beta, 2z 0, then it is divided by 2, and this is also 0 divided by 2. After that, we find the point of intersection method, that is hg. Here students, b, f, h, again we know that b, f, h, again b. This is alpha by hf minus bz. Beta by, this is alpha, this is beta, this is 1. gh minus af, 1 by ab minus h square. Okay students, hf minus bz, gh minus af, ab minus